Alright, so let's look at some integrals here. We're using partial fractions, and here's some properties that we go by when we're doing the partial fractions. I'm not going to go over them in this video. This is my third example. If you want to hear me talk about these properties here, you can watch the example 1 video. I go over them in that video. Alright, so let's go ahead and get started. Let's let's look at our third example here. We have 2x cubed minus 4x minus 8 over x squared minus x times x squared plus 4 dx. Alright, so the first thing that we need to do is take the denominator and factor what we can. So I have x squared minus x times x squared plus 4, and I'll factor x out of here, and then the x squared plus 4, that can't be factored, so I'll leave it like that. So now let's go ahead and write our 2x cubed minus 4x minus 8 over x squared minus x times x squared plus 4, and that's going to be, okay, so we've got a over x, that's this factor, plus b over x minus 1, this factor, plus, and now this is a quadratic factor, so we're going to have to write this as c times x plus d over x squared plus 4. Alright, so now, and this right how this is written, you'll be able to, you can see that. We go over it in the first video. See if it's if we have a squared here, then it's the bx plus c, and of course I had to use cx plus d because I had already used a and b. Alright, so let's get back to our problem. Alright, so what I need to do now is I need to multiply by the common denominator, which is x times x minus 1 times x squared plus 4. Now, when I multiply by this term here by the common denominator, this all cancels out. So I'm left with 2x cubed minus 4x minus 8. And then when I multiply this term by the common denominator, the x's cancel out, and I'm left with x minus 1 times x squared plus 4. So that's a times x minus 1 times x squared plus 4. And then I multiply this term times the common denominator. The x minus 1's cancel. So I'm left with bx times x squared plus 4. And then when I multiply the common denominator times this term, I'm left with x and x minus 1. So that's going to be plus cx plus d times x. No, I don't have to put that in parentheses. So that's going to be times x minus 1. Alright, so now we need to try to figure out what a, b, c, and d are. The a, the b, the c, and the d. So I can plug them in here. Alright, so the first thing I'm going to do, I'm going to let x, I'm going to go ahead and just let x equal 0. And what that'll do is get rid of this and this, and I'll be able to solve for a. So I'm going to let x equal 0. Alright, so I plug the 0 in, and what that does is that gets rid of this term and this term, because I have 0 here times all of that is 0, and 0 times being 0 squared plus 4, that is 0 also. So when I do this right here, I'm going to get negative 8 equals negative 4a. So that's going to give me a equals 2. Okay, so there's a equals 2. So there's my a. I'll plug into there. Now let's see what I can do. How about if I let x equal 1? If I let x equal 1, that's going to take this out, and it's going to take this out, and I'll be able to solve for b. So let me go ahead and do that. So I'm going to let x equal 1. So that's going to be 2 times 1 cubed minus 4 times 1 minus 8 is a times 1 minus 1 times 1 squared plus 4 plus b times 1 times 1 squared plus 4 plus c times 1 plus d. Alright, and so then that's going to be times 1 minus 1. Alright, so you can see the 1 minus 1 is 0, so that's going to take this term out. And the 1 minus 1 equals 0 here, that's going to take this term out. So once I do all my arithmetic, that's going to leave me with negative 10 equals 5b. So that's going to give me b equals negative 2. And so there's my b term. Alright, so now as you can see, there's nothing else I can do. I've already plugged 1 in to get a 0, and I plugged 0 in to get rid of the terms, but there's nothing else I can plug in. There's nothing I can plug in for x here, because anytime I square it, I'm going to get a positive, so I'll never get negative 4 plus 4 here to go to 0. So what I can do is I'll pick a couple other numbers. Okay, so let's see, we picked 0 and 1. So how about we go to the other side of 0 and we choose negative 1. So I'm going to let x equal negative 1. And you can choose any number you want, but just try to keep the numbers as small as possible. So let's go ahead and plug in the negative 1. So I get 2 times negative 1 cubed minus 4 times negative 1 minus 8 is a times negative 1 minus 1 times negative 1 squared plus 4 plus b times negative 1 times negative 1 squared plus 4 plus c times negative 1 plus d times negative 1 times negative 1 minus 1. Sorry about writing small, but I'm trying to get it all on one line. And then once I do all of my arithmetic, and let me go ahead and do this first. It might make it a little easier. So I have A. I know A is 2, so let me erase the A here and put a 2. And then I have B is negative 2, so let me go ahead and erase the B and put negative 2. And then let's see if I can squeeze this in. Let me redo that. So that's plus, and that's going to be negative 2 times negative 1. Okay, so I just replaced the B with negative 2 and the A with 2. And so once I do my arithmetic here, that's going to give me 2 equals negative C plus D. Alright, so you can see here that I have two variables. So now I need to let X equal something else. So this time I'm going to let X equal 2. And so I plug the 2 in, and I'm plugging the 2 into this right here. Okay, so when I plug the 2 in, I've got 2 times 2 cubed minus 4 times 2 minus 8 equals A. Now in the place of A, I'm going to put 2 because A equals 2 times 2 minus 1 times 2 squared plus 4 plus B. Now B is negative 2, and then times 2 times 2 squared plus 4 plus C times 2 plus D times 2 times 2 minus 1. And then once I do my arithmetic here, I get 8 equals 2C plus D. Alright, so what I have now is I have a system of equations. I have 2 equals negative C plus D, and 8 equals 2C plus D. Now I have to solve this system of equations for C and D. So to do that, well, I can get rid of the D's, so I can multiply this times negative 1, so that's going to give me 2 equals negative C plus D, and that's going to give me negative 8 equals negative 2C minus D, and then I add them, so that's negative 6 equals negative 3C, and so I get C equals 2, and then I take the 2 and I plug it back in, and I'm not going to show that work, and I get D equals 4. So now I have A, B, C, and D. And so what I'm going to do now is I'm going to plug that back into here. Okay, and when I plug A, B, C, and D in, I'm going to get, and I'm going to go ahead and write my problem again. So that's 2x cubed minus 4x minus 8 over x squared minus x times x squared plus 4 dx equals the integral. And now I'm going to do my partial fractions, and so that's going to be 2 over x, a is 2, plus b over x minus 1, and b is negative 2, so the plus and minus will make a minus, and then that's going to be plus c is 2, so 2x plus, and d is 4, over x squared plus 4 dx. Alright, so now I have to integrate this. So this one and this one's easy. These are just going to be natural logs. But let's take a look at this one. Well, that's not really don't really have a property for that. So what I'm going to do is I'm going to rewrite it. And I'm going to split this up. So I get 2x over x squared plus 4 plus 4 over x squared plus 4 dx. And so we know this is natural log and this one's natural log. So this is going to be 2 natural log absolute value of x minus 2 natural log x minus 1 plus, and then this one's natural log also, because you can see if we take the derivative of the denominator, we end up with the numerator. So that's going to be plus natural log absolute value x squared plus 4. And then this one, you can go back and look at your properties, but this one is going to be plus 2 times the arctangent of x over 2, and then all that is plus c. And so this would be our final answer. And I hope this video's helped. I hope you'll check out my other videos, and if you like them, you can subscribe. Alright, thanks.